Hi everyone, welcome back. Let's see FCFS algorithm with an example. Right? FCFS means first come first serve, where the mode we are using is non-preemptive and the criteria we are following is arrival times. The dataset what they have given is process ID, arrival time, burst time, and you have to calculate starting time, completion time, turnaround time, waiting time, average turnaround time, average waiting time, and what is the scheduling length, what is the throughput. You have to calculate, right? So for that we'll go with Gantt chart. So if I assume this is a CPU, and which will generally start with 0 nanoseconds. Guys, at the arrival time of at the CPU starting 0 nanoseconds, is any process has arrived? No, right? No process has arrived for 0 nanoseconds. So which process arrived at the recently least, that is 3 nanoseconds. So which means that CPU is idle for how many nanoseconds? 3 nanoseconds. After 3 nanoseconds, P3 will be allocated and will complete execution for 5 minutes. Means it's going to end it by 8. By the time of 8 units, P1 will come and P5 also arrive. So between P1 and P5, which one will get the first priority? P1 will get the priority because its arrival time is less than the P5 arrival time. So P1 will serve first, whose burst time will be again 5. It will complete by 13. As it completes the 13 nanoseconds, what are the process that might be available for us? So this is done, and P2 will be available, P4 will be available, and P5 is also available. Out of this, which one will get the first chance? First chance will be given to P5. It will be executed for 6 nanoseconds, that will be 19. So done. Once 19 nanoseconds are done, middle you will get P6 also, right? Which means that now P2, P4 and P6 are ready to execute, and remaining all are done, right? So out of these 3 processes, which will get the first serve? P2 will get a serve because it is arrived at 10 nanoseconds. So P2 work for 3 nanoseconds and it will be done by 22. Done. Then P4 will serve for 2 units, that will be 24. Then finally it is P6 will serve for 4 nanoseconds or 4 units, it will be done by 28. Based on this Gantt chart, can you fill the table? Yes. So starting time of process P1 will be 3, completed by 8. Is it the correct one? No. Observe guys, process P1 started at 8 and completed at 13. Process P2 starts at 19, completed by 22. Process P3 starts at 3 and ended by 8. Process P4 starts at 22, completed by 24. Process P5 starts at 13 and completed by 19. And process P6 starts at 24 and completed by 28. Now, what is turnaround time? Difference between completion time minus arrival time. 13 minus 5, which will be 8. 22 minus 10, 12. 8 minus 3, 5. 24 minus 12, that will be 12. 19 minus 8, 11. And 28 minus 15, that will be 15, right? So now calculate turnaround time for all the things, that is 8 plus 12 plus 5 plus 12 plus 11 plus 15 by 6 is the turnaround time, and calculate it and make it answer in the comment section. Average waiting time. Waiting time is turnaround time minus burst time. Turnaround time is 8. 8 minus 5 will be 3. 12 minus 5 7. 5 minus 5 is 0, like turnaround time minus burst time, and 12 minus 2 10, 6 11 minus 6 that will be 5, 15 minus 4 that will be 11. If you calculate average waiting time, that will be 3 plus 7 plus 0 plus 10 plus 5 plus 11 by 6. And what is the scheduling length? So scheduling length means the maximum completion time of all processes, that is 28 minus minimum arrival time of all processes, that is 3, which is equal to 25. And what is throughput? 6 by 25 is throughput. And how about CPU efficiency? Efficiency of the CPU is, what is the total time taken to complete all the process, that is 28. How much time it is effectively utilized? 25 by 28 into 100%. That is, what is the CPU inefficiency? Inefficiency will be 3 by 28 into 100. Okay. So like that you can able to get various kind of questions. You can able to solve it clearly once you are able to understood everything clearly. Okay. Hope you understood this video clearly. Thank you.